Open up 9.5. We're going to do summations again. Now, we already saw summations in the unit with series and sequences, if you remember. So how would I do if I were given this question, I equals 1 to 4 summation of I? What would I do to solve it right now? How could I just get an answer like that? How would I get an answer? Use the, in the template key, there's the summation. It's highlighted in blue. But what we want to do is we want to do these out now. And do these out kind of by hand. Does anybody remember, we did touch on it when we were teaching series of sequences, how to do these by hand? What the process is for going through? Anybody remember? A times B, kind of. What are we plugging in? And then 2, and then 3, and then we're plugging in each natural number. We start by looking at the lower bound, which is the number on the bottom of the summation. And then we continue, we go in each value. So if it starts at 1, then we go 2, 3, 4, up to whatever we have for our upper bound. And then we just sum the terms. We add up all the things that we just found. You got your stuff? You're good for that. So let's give it a shot. I equals 1 to 5 to 2i. What am I going to plug in? Sandra, what's the first term? What's the first term? 1. So what am I going to plug? When I plug it in, what's the term? I mean, yeah, I'm going to have 2 times 1. All right, go around the horn on this table. What do we got? 2 times 2, and then 2 times 2, and then 2 times 3, and then, keep going, keep going. We're going around. Do you guys know what around the horn means? Around the horn means you just go around the. Okay, do we need another one? Why don't we need another one? Yep, we're only going to 5. That's our upper bound. So we started with 1. We started with 1, and then we went up to 5, each number in between. So now we just got to add it up. 2 times 1 is 2. 2 times 2 is 4. 6. 8. 10. 2 plus 4 is 6. Plus 6 is 12. Plus 8 is 20. Plus 10 is 30. We evaluated our summation. All right. Get a little more complicated. Everybody give this one a shot. Plug in. First plug in and then simplify it. Everybody give it a shot right now. All right. So go to middle table. Go around the horn. What'd you guys get? Middle table, that's all. So you have 4 squared. You started with 4, and you plugged it in for x. And then what'd you get? Keep going. See, around the horn means you go around the, like around and around the table. Okay? Plus 6 squared. Plus 7 squared. Plus 8 squared. Plus 9 squared. Plus 10 squared. Remember, summation, we're adding up each one of these. All right? And now we just got to simplify it. 16, what do we get here? 25 plus, 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 plus. Okay? This one, now go to the calculator, try and plug this in, see what we get. 371. 371. All right. All right. I was going to do one more for you guys, but I think you guys are starting to pick up how to do this, right? All right. So let's take a look. A little more interesting and probably more along the lines of what they're going to ask you on the test is to give you the reverse. what they're going to do is they're going to give you a series, like addition, something plus something plus something plus something plus something. And what you're going to have to do is figure out the pattern and put it in summation notation. So we have to take a look here. We have to find the pattern. So we have 9 plus 16 plus 25. What's that dot mean? Continuing and so on up to 100. Does anybody see a pattern that is going on here? They're all perfect squares, yeah. How did we get 9? 3 squared. How did we get 16? 4 squared. We got 25 from 5 squared. We keep that going until 10 squared. Okay. That's the first step to doing these, is to rewrite the numbers that they give you, which are kind of, there is a pattern to these, but there's not extremely clear just by looking at them. Rewrite them so that what you end up with is something that changes and something that remains constant. So here the base changes each time and the exponent remains constant. That's essentially what you want to get, because that's how our formula is going to look. Or if some variable, it's going to change and the rest of the stuff remains constant. So how would I put this into a summation? If I wanted to write a summation. X equals 3 for what? On the bottom. Now, why are you starting at 3? Yeah, well, the first number you plugged in right here is 3. Yeah. And what do we go to? 10. How come? Yep. Well, just look right here on this one. It's usually easier. The last number we plugged in is a 10. The first number we plugged in was a 3. The last number we plugged in was a 10. What was our pattern that we used? X squared. Now you can do, and that's all it is. You can do, when you're writing these, you can use any letter you want. You can use I, you can use X, you can use N, you can use Z, but you must remember to keep it consistent between these two. Whatever you put here is what you're plugging in. Because if I had, like, in a different summation, X squared times A, I'm only going to be plugging in for X squared. I have to plug in something else for A. So you guys don't have to worry. You guys won't have to see. You guys won't see those, but just be conscious that you have to keep it consistent. All right. That's just the same thing twice. Take a look at this one. This pattern's a little more complicated. Try and rewrite this as something where it changes and then doesn't change. This one's a little tougher. You're going to have it's not just one term anymore. It's like you're going to have to add stuff. Add, subtract, multiply. Let's take a look at this. What kind of series is this? This is a series, right? We're adding up different terms. What kind of series does it mean? Is it? It's what? Arithmetic. Why is it arithmetic? Yeah, we're adding. To go from -6 to -3, what do we do? And to go from -3 to 0, what do we do? And to go from 0 to 3, we added 3. So we're adding 3. So what you're going to see is our rule actually kind of follows our arithmetic series formula. So if we know it's an arithmetic series, and we're trying to write a formula, what's the first thing I have to put in? So it might be easier here to write the formula first. What's the first thing I would put in the formula? The first term. The first term. What's the first term? What's the first term? -6. Where'd you get? I don't know where you got -9 from. Yeah, But I'm not talking about the lower bound. I'm talking about the first term of the formula. And then what do we need? Or what? Plus 3 times what? What does 3 represent? Or what? What do we say 3 was in this series? It goes up by 3, so what do we call that? What, guys? Come on. We just did series like 2 weeks ago. What do we call it? Common difference. It's the common difference. And we multiply the common difference by the term that we're on, right? What do we call the term that we're on in the summation formula? N, X, whatever you want to call it. What letter do you want to use in the summation formula? X, okay. So if we know that, what would we have to put in for our lower bound? Where would it start to get -6? I'm plugging this in for X. If I plug in 1, I'm going to have -6 plus 3. So I get negative. So I would get -3, but I need to get what? I need to get a -6. 0. X equals 0 is where we start. See, because if I plug in a 0, I'm going to get that. Now let's try it. If I plug in a 1, what do I get? If I plug in a 1. We're plugging in a 1 for X. Because we started with 0. Right? What we're saying, if we say that X equals 0, then the next thing we'd have to do is plug in a 1, right? Then the next thing we have to do is plug in a 2. And the next thing we have to do is plug in a 3. So try it. If we plug in a 0, okay, we get -6. If we plug in a 1, what do we get? If we plug in a 2, what do we get? 0. If we plug in a 3, what do we get? 3. Okay, does this look like it's working? So the only last thing to figure out is where do we stop plugging in? Well, we want to get 15, so what would we have to stop plugging in? Don't just guess, think about it. What we need to get that to be 15, right? So 15, I mean, you can think of it as an equation if you want to. If I plug in a 7, if I plug in a 7. If you're really stuck for that one, you can just say, okay, -3 plus 6, -6 plus 3x. We want it to equal 15. So 3x equals 21. X equals 7 if you're stuck. Okay? Making a little more sense. We're doing one more. We're going to write this in summation notation. All right? Remember, try and rewrite it as a pattern. Try and find the pattern in it. I'll give you guys a little hint. What kind of series is this? The multiplication one, which is called the geometric series. So what do they have? They don't have a common difference. They have a common ratio. What is it here? 5. There's one more hint. In the last one, we had an arithmetic, right? And we multiplied. We had the 3 times I. Here we have a geometric. What are we going to need instead of multiplication? Not division. What was, now remember, in the other one it was an arithmetic. We added to get each one. So to get repeated addition, we use multiplication. Here we need repeated multiplication. We need what? An exponent. We need exponents. And keep in mind what a negative exponent does. What does a negative exponent do? Makes it gives it a fraction. All right. Let's go. What's our pattern then? What's our pattern? We're multiplying by 5. Yeah, so how do I rewrite this? As what? If I want to multiply this by 5. In other words, we know the pattern is multiplying by 5. How many times did I multiply 5 to get this? Huh? 5, yeah, 5 times 5, so that's 1 time we multiply by 5, but it's in the denominator, right? So how can I rewrite this using exponents? Not just 5 squared. 5 to the negative 2. 5 to the negative 2 is 125. 1 over 120. 1 over 25. How do I rewrite 1/5? Five to the negative 1. What's 1? 5 to the 0. 5. 5 to the first. And so on. What's 625 written as 5 to the something? 5 to the 4th. 5 to the 4th. All right, so I have to write this in summation notation. What did I start by plugging in? What did I start by plugging in? But what is the first number that I plugged in? I'm trying to do my lower bound. Oh, what was it? Negative 2, yes. What letter you want to use? X? We use X again. Started at negative 2. What did we end with? 4, positive 4. What's my formula? Five to the x. That's all we need, 5 to the x here. See, look up here. Each of these different terms, 5 remain consistent each time, and all we did is change the exponent. So 5 remains consistent. All we do is change the exponent. Right? All right, so your homework is pages 18 and 19. For the ones that ask you to do out the summations, try and do out the summations. And what you want to pay attention, try and get a feel for, okay, when the summation looks like this, when the formula looks like that, this is what the pattern looks like. So that way when you get to the second part, you can kind of see a little bit more what the patterns look like. You have to do these out and get a feel for what patterns come where. I know it's kind of hard now, but as you do these, they'll become more repetitive and you'll start to see patterns look almost exactly the same. All right, should be going right about now, right? All right, let's see, I collected your weekly projects. All right.